Hello, class. This video is now going to be Lab 8.6, Part 2, as can be seen up here on the video. When you click on the link, this will come up, and this is called Resistance of a Wire Challenge Lab. So, introduction. For this challenge lab, you'll be trying to determine the resistivity of a wire based on a graph of resistance versus length. Here are some instructions on how you should be able to do it. I'll go ahead and select Begin here. And notice here I'm given a battery, which is at 1.5 volts. So when you see that, you'll probably want to put that like right here. 1.5 volts for right there. And the area, now to get the area, let's go ahead and show the area. And each grid is 0.1 millimeters. So make sure we get the radius, convert it to meters, and do pi r squared to get the area. So we'll go ahead and hide the area, and that should go here. So the voltage and the area of the wire is not going to change. Now, down here, we have a table here in which we need to collect some data. It has here 5 trials. I'm going to go up here and show ruler. So I hit ruler, and these are some electrodes, a positive electrode to the positive terminal and a negative electrode to the negative terminal here. So, and we would do this lab for real if we're, in class. Had we had real class, we would do this lab for real. But however, I put a terminal here at 1 meter, and here's the wire. I put it here, and I put it at 1.2 meters. So from here to here is 1.2 meters, and that will be the length. I'll put right here as 1.2 meters. Now to get the current, I'll need to hit the current here, and this is given to us in amps. So each dot is 0.1, 0.2, 0.3, 0.4, 0.5 amps. So this here I'm going to estimate about, well, we'll say 0.14 amp. So I would put down here 0.14 amp, and the length of the wire I have here is 1.2 meters. 1.2 meters. Now from here, I need to calculate resistance, and I'll use voltage divided by current. So the voltage up here, I had 1.5 volts, and I would calculate my resistance here from using Ohm's law. I would complete this. So then that's for trial 1. Trial 2 is a new length and a new current. So I'll go ahead and record those here and here and calculate the new resistance here. And I will go to trial 3, repeat it for trial 3, trial 4, and finally trial 5. So once I complete this table here, I'll go down here, and this is my quick graph table here. So I'm going to use the length from up here, this length here, I'll go ahead and transpose to here, as well as the resistance here, I'll go ahead and put here. So this will be X and this will be Y. For my 5 trials, I'll go ahead and use quick graph. I will get hopefully I will get a straight line slope. So what the graph should look like, let me go ahead and go here. It should look like this. Once I plot the table here, the graph should have this feature right here. We'll have resistance here. I will have length here. And my 5 points should be something like this. I should get a straight line, linear, and I should get the slope. And from there, I should be able to calculate the resistivity. And let's kind of see what that might look like. So here's resistance. Here is resistivity divided by the cross-sectional area times L. So here I have resistance resistivity times L divided by A. But if I kind of group this together here, my slope, this should equal the slope. And once I get that, I should be able to calculate resistivity. And so once I'm done here, I'm going to put my name in here, submit, and I should get a certificate that says good job. And once I get that, I want to copy and paste that into the box here, and away we go. All right, thank you. Any questions, feel free to contact me.